The next part of this video, we are going to look at variance and standard deviation. I know these are intimidating terms, and from a statistics point of view, a little more complicated than the others. But if you think about them fundamentally and follow along with this example, I promise you it won't be that bad. So when we talk about variance, actually, let's move back. And we talked about range in the last video. If you recall, a range is our minimum value and our maximum value, and the difference between the two of them. You take the max minus the min, you get the range. So the range of all of the data, in the case of a scale from 1 to 7, is 6, right? Let me go ahead and fix that back. So we have in this data, I'll show you here, frequencies, analyze descriptives, frequencies. Let's choose total let's choose waiting time for other borders. We'll go to statistics, and here we'll choose all of the same selections that we had in the previous video. So we had mean, median, mode, minimum, maximum, range, skewness, and kurtosis. And hit continue and OK. So this is the same result as we had in the last video, just with that one data point corrected because we had one respondent say 1. So here we are. So we had 120 valid cases, 0 missing. Excellent. We had a mean of 4.2667, meaning from 1 to 7, the average response in our survey was 4.2667. The middle number was 4, and the most frequently occurring number was 5. Our skewness we talked about, and kurtosis fitting within that range of negative 0.5 and positive 0.5. Although the kurtosis is slightly above that range, it would still be accepted from a social science perspective. So that fits within the kurtosis and skewness standards when it's rounded. Next was the range. So here we had the somebody who responded 1, at least one person. Let's see, 2 people that responded 7. So our range of responses was 6. But what if we wanted to know the spread of the responses from the mean? So what if we wanted to think about this range of 6 and how it relates to that mean of 4.2667? In other words, how distributed are the responses in our survey? In one case, you might find that, for example, everybody chose 3, we'd have a mean of 3, and we'd have a range of 1, right? It would be 3 minus 3, actually 0. So, but just for argument's sake. So in that case, we would have no variance. There would be 0 variance because everybody chose the same number. Inversely, what if we had a mean of 3.5 and a range of 1 to 7 and equal responses across all numbers? So a range basically of 6 with equal responses across all 7 numbers. That way, we would have a very large variance, right? There would be a big difference in the responses because not everybody chose the same number. So let's have a look actually and see what SPSS tells us about the variance. So we'll go to descriptive, frequencies, statistics, and now we're going to choose variance and press continue and then OK. So it's the same data as before, all of the same information. However, now we have a new row called variance. The problem with variance is it's an unstandardized value. So you can't easily fit this 1.592 onto your Likert scale. In other words, you can't say that your data varies from the mean by 1.592 because that is a measure of the variance. In other words, you take the sum of each response minus the mean squared and then divided by the n, and you end up with the variance. It's not until you take the square root of that variance that you can determine how far away each response is relative to the mean of your data. So let's go back to analyze, descriptive, frequencies, statistics, And finally, we're going to choose standard deviation and press continue and OK. So here we have the data, same as before, but now we have not only variance, but standard deviation right above it. So the standard deviation, if you took this number, 1.592, and did square root of this number, you would end up with 1.26181. And if you look here, the range of 6 relative to the mean of 4.2667 shows us a standard deviation of 1.26181. So each data point, for instance, if we chose participant 3, they chose, 8, right? Participant 3 chose 8. 8 relative to the mean is higher than the mean, so it is whatever that, at 3.7 something points higher, right? If you kept doing that down the list, on average, by the time you got to the bottom, your responses would sit about 1.26 away from the mean of the data set, okay? This standard deviation is an indication of the spread of your data. So again, if you only had one response, so let's do that. Let's test this out. So let's say rather than a bunch of different responses, we had a category that was, we'll call it reason 5. And so for reason 5, and we'll choose all the same information. Why can't, okay, anyways, doesn't matter. So, here, numeric, scale, and this is just variance example. Okay, so here we have data, and we'll just say that everyone answered 4. So let me do this a faster way. Put 4, 4, 4. We will get 120 instances of 4. Copy that into our data set. So here we have every single person in our survey answered 4. Do you think the standard deviation will be higher or lower in this case? And if you said lower, you'd be right, because there's a small spread between the numbers. In fact, there's no spread. So here we're going to go analyze descriptive frequencies. We're going to use our variance example and keep all of the other options selected. So let's see what that looks like. So here we have a range of 0 because the number minimum and maximum are the same, 4 and 4. 4 minus 4 is 0. We have a mean of 4, a median of 4, and a mode of 4. And now look at our standard deviation and variance. 0, because there is no variation. In other words, there's no spread of numbers from 4. They are all 4, okay? Here, we know that that's not the case. They're not all 4. They're a range from 1 to 7. Therefore, we have a spread of information, of data, and that spread is represented by the variance. The square root of that is represented by standard deviation, which gives us an indication of how far away from the mean each value on average sits. I hope this has been helpful to explain. In the next video, we'll look at charting variance and standard deviation to better understand its role in relation to the mean.